Assalamualaikum warahmatullahi wabarakatuh and a very good day to all of you. Okay, so today kita akan sambung our fourth subtopic for chapter 4, which is gas law. Okay. Okay, so before kita start dengan gas law, we have to know first all the properties of this called as gas. Okay, macam mana gas tu sebenarnya dia punya properties, apa dia punya karakteristik, dia bergerak macam mana, what influence the gas movement ke apa benda ke, kita akan tengok dalam kinetic theory of gas. So we'll watch this one simulation. This simulation you boleh tengok dalam buku teks. So just scan the QR code and you will see lah this simulation. Okay, let's see. Alright, so this is the gas simulator ataupun the gas law simulator or whatever we want to see about gas, we can see it here in this simulator. So kat sini kita boleh ubah dia punya volume. Oops, dia punya volume. Okay, you nak increase, you nak decrease, you nak stop, you tekan 2 kali lah. Okay, and also kalau kita nak tutup the balang, and then kita just tutup with this apa ni, kunci ni. Nak tutup meaning kita tak nak dia keluar lah. So kita boleh kunci dia, tak nak kunci dia suka hati. So kita ada pressure here. Okay, pressure ATM. And then kita ada temperature here yang kita boleh heatkan. So pressure akan jadi more lah. Kita akan coolkan. Pressure akan jadi a lot lah. Okay, alright. So kita ada dua jenis gas. Gas A is sekecil daripada gas B. So gas B is bigger. So kalau kita nak pump gas masuk dalam ni, kita tekan je pump ni. No gas selected. Okay, so I select gas B, so I pump, dia akan masuk banyak gas B lah. And then I nak gas A pula, I pump, dia akan pump both sebab I buka dua-dua. So kalau I tak nak buka salah satu, I kena klik lah bagi dia jadi kecil macam ni, meaning bukan gas tu yang kita nak gas A je. So you can keep on pumping gas A, dia masuk lah banyak-banyak kan. Gas B, you nak gas B je banyak-banyak, pump. Contoh kalau you nak redo all this gas banyak sangat, tekan je this one. Tekan lagi sampai you buang lah ni. Ni kita buang the gas. Alright. And at one point you nak buang semua, buang je semua dulu. Okay. So I nak tunjuk kat you gas je sebenarnya. So kita guna gas besar lah, nampak sikit. I pump it up. Pump lagi banyak sikit. Okay, now. So this is how the gas behave. Okay, kalau awak tengok sekarang ni gas dia move ada direction tak? Dia move ikut suka hati dia. Okay, nak pergi kiri, nak pergi kanan, nak pergi depan, nak pergi belakang. Suka hati tok nenek dia. Saya nak kunci lah. Okay, bila kita kunci meaning this one can the piston cannot move. So kita nak tengok apa yang jadi bila kita increase the temperature. Awak tengok betapa randomnya dia bergerak. Okay, kita heatkan dia. Bila kita heatkan dia, nampak tak pergerakan dia lebih laju daripada kita tak heat. Lepas tu pressure pun increase kan. Okay, pressure datang mana? So pressure datang daripada the collision between this particle dengan wall of the container. I don't know lah. This one sebab dia internet punya bukan PDF lah, punya ni. So I cannot have anything to point it out. So faham je lah bila saya kata wall of container yang mana. Ni lah silinder ni punya wall. And then, okay, first apa saya nak cakap tadi? Okay. So pressure dia akan increase lah bila dia langgar dengan this container punya wall. Lagi banyak kali dia langgar, lagi banyaklah pressure. So sebab itulah bila kita increase the temperature, awak kena tengok dekat average kinetic energy belah kanan atas ni. Okay, tengok bila saya increase the temperature, average kinetic energy pun increase. Tadi 5 something, sekarang 7.48. So kalau kita cool it down, average kinetic energy pun berkurangan. Bila berkurangan, kita punya gas pun slow down lah kan. Temperature pun decrease, pressure pun decrease sebab dia punya collision dengan wall ni dah tak banyak. Frequency of the collision dah tak banyak. Okay. Okay, that's what happen bila untuk gas law lah. Ni gas law, gas punya behavior. Okay. Temperature, dia effect dia punya average kinetic energy. The higher the temperature, the higher the average kinetic energy. Okay. Alright, so from this simulation, we have seen how gas behave bila kita ubah the volume, bila kita ubah the volume, bila kita ubah the temperature, and then what happened to the temperature, you can see, right? It's different lah each time. Okay, so use the scan the QR code and play with this so that you will be apa ya dia? Okay, awak akan lebih faham lah. Okay, how the gas actually behave. Alright, now let's make a conclusion on the theory of gases. So movement, apa yang kita nampak tadi ialah gas molecule move randomly. Kan, dia pergi merata ceruk kan. Gas molecule always move randomly. Lepas tu kalau awak perasan tadi dalam that container, bila dia bergerak dia akan berlaga dengan dinding-dinding ni kan. Okay, this collision create pressure. Now, okay, collision between the gas molecule and the wall of the container create pressure. That's why bila temperature increase tadi, bila benda ni bergerak lagi laju, kalau awak perasan dekat ATM tu dia also increasing. That means dia punya collision with the wall tu semakin banyak. So that's why pressure dia increasing bila temperature increase. Okay, this one kita akan belajar more in pressure law sekejap lagi. Tapi ni saya terang in general dulu lah apa itu kinetic theory of gases. Okay, so again, for the average kinetic energy, kita perasan tadi bila kita change the temperature and then average kinetic energy also increasing. So they have a very close relationship. Okay, tapi bila pressure or volume increase, average kinetic energy tak ada effect sebab dia hanya di effect oleh temperature. Okay. What else? Okay, volume pula, bila volume dia bigger, gas tu boleh move more freely lah. Kan, dia boleh naik atas, dia boleh turun bawah. That one. Okay. And also, tapi bila volume kita kecil, dia tak boleh nak move sangat. Dia tak boleh nak bergerak sangat. Therefore, kalau perasan pressure dia akan increase sebab dia boleh bergerak in a closed space je. So, jadinya dia punya collision with the wall pun akan jadi more frequently. Okay, because pressure, dia punya connection ialah how pressure is created bila molecule bump dengan ataupun rebound dekat ni apa? Container, the wall of the container. Okay. Okay, so that's that for kinetic theory of gases. Okay, ni saya dah masuk sekali kan pressure, movement, volume and also temperature. These three quantity yang memang highly affected lah the gas. Okay, yang nampak obviously affected the gas. Alright, now let's go to the first law, which is Boyle's law. Okay, Boyle is just a scientist. Dia yang jumpa this law. Alright, first of all, bila kita tulis law, sebab nanti dia akan tanya, state the name the law involved ke apa benda, make sure ejaan ni kena betul because this is someone's name. Okay, bila name tak boleh salah. Ejaan kena betul. B-O-Y-L-E apostrophe S law. Okay, Boyle's law. So Boyle's law, he is talking about pressure is inversely proportional to the volume for a fixed mass of gas at constant temperature. We also see this just now yang saya tunjuk tadi tu, bila these gases, bila saya temperature dia constant, contohlah 300 Kelvin, and then kat sini ada volume kan, kat sini ada pressure tadi kan, ATM tu. So bila saya decrease the volume, and then this particle akan bergerak, dia bergerak sama kinetic energy sama, cuma dia punya frequency, meaning kekerapan dia berlaga dengan the wall of container is more. Jadi pressure dia pun akan increase bila volume decrease. That's why diorang ialah inversely proportional. So kalau graph tu P and V, you will have a inversely proportional graph. Okay, exponential graph. Okay, now So, this one the frequency of the collision with the wall equals to frequency. Okay, so the higher the frequency, the higher the pressure. Okay, kita ada formula untuk Boyle's law. Kita macam mana kita nak cari formula dia dengan tengok relationship. So relationship dia P is inversely proportional to V. Jadinya kalau graph, saya buat graph lah. Graph. Okay, so if graph, you will have P N1 over V. And then kalau P dengan V kan. Okay. So kalau P dengan 1 over V, dia akan jadi directly proportional. Kalau P dengan V, dia akan jadi inversely proportional from this relationship. Okay, untuk mendapatkan formula selalunya, kita akan letak satu constant kat depan ni. Okay, so P equals to a constant, 1 over V. Constant ni can be any value lah. Alright, so bila kita, okay, K is just a constant, T is absolute temperature in Kelvin. So gas law always use Kelvin. Volume is just M cube. Ni apa M3 ni M cube, okay. Jadinya, I'm sorry, terbalik ni P lah. Pasal apa? Pressure in PA. I dah terbalik dah ni. Sorry, not this one. I'm sorry. Okay, so pressure and volume tak adalah. Okay, bila pressure and volume apa saya nak cakap tadi? Okay, so untuk Boyle's law, kita ingat tadi kat depan dia punya statement, dia kata pressure is inversely proportional to the volume provided that temperature kena constant. Okay, so in Boyle's law, temperature is always constant. Boyle's law, because in Boyle's law kita nak tengok relationship antara pressure and volume. Alright, so now we see that P equals to K 1 over V and K over V lah. P equals to K over V. Okay, so again P equals to K over V. Okay, bayangkan kita ada dua situation. Okay, so P1 dengan V1, P2 dengan V2. So equation for this one will be P1 equals to K over V1, and this one P2 equals to K over V2. Okay, let's jadikan K to subject. So kita akan jadi P1 V1, and then this one will be P2 V2. K, this constant will always be the same number. Okay, just a constant kan. Contohlah kita letak sini 1. Sini 1. So K, dua-dua ialah 1. Jadinya because of both are 1, kita boleh make a conclusion that P1 V1 equals to P2 V2. This one is the conclusion for Boyle's law. Okay, sebab sama je dia orang. Just a constant. So P1 V1 equals to P2 V2 bila kita ada dua situation yang involve Boyle's law punya dua situation. Okay, kenapa kita kena tahu generalization ni cikgu? Okay, because we will use this untuk cari pressure or volume for anything. Okay, bila kita ada dua situation, Boyle's law, gas law, always akan ada dua situation. This one kita akan guna dalam solving problem sekejap lagi kita buat. Tapi for now, you have to know that Boyle's law, pressure is inversely proportional to volume provided that the temperature is constant. And then because of the temperature is constant and because of this relationship, we can finally make a generalization that P1 V1 equals to P2 V2. So this is Boyle's law punya generalization untuk cari P1 or V1 or P2 or V2. Jadi saya terang macam mana dia punya solving a problem. Okay? Okay, now let's see the experiment. Okay, dalam setiap gas law ni kita ada experiment, alright? The link for the experiment I will paste it in my description. I will type it there. So nanti awak klik lah kat situ. This experiment made by us, Marcel Lenggong, saya dengan Cikgu Zul buat. Okay, so eksperimen ni kita nak tengok Boyle's law. Jadi apa yang kita buat ialah kita ada piston. Piston ni macam shrink tu lah shrink, and then kita ada piston. So kita ada pressure punya meter, which is kita panggil as pressure gauge. Tak nampak pula. Sekejap. Okay, pressure gauge dalam ATM selalunya. Okay, so jadi je kita buat apa ialah first kita draw dulu ni naik atas, maksudnya kita draw the air inside. So contohlah kita ambil 100 ml of air. Contoh, okay. So kita ambil 100 ml of air. Sebelum kita bagi any pressure to this air, this meter will be 0 lah. Okay, pressure gauge punya meter will be 0. Okay, sebelum tu make sure connection dia kena tightly, betul-betul tight. Kalau tidak nanti awak punya pressure ni cannot hold. Dia akan turun naik, susah nak cari susah nak cari data. Tapi senang cerita dia kena airtight lah, sebab kita nak constantkan kita punya number of air particle. Okay, particle dia kena constant. So that barulah temperature dia akan jadi sama je. Remember average kinetic energy. So temperature dia kena constant Jadi kita punya air, molecule of air dalam ni pun kena constant. Kalau benda ni tak tight, nanti akan ada air yang boleh masuk, air yang boleh keluar. So jadinya kita punya dalam ni dah tak constant. Okay. Alright, so now kita akan press this piston. Contohlah tu tadi start dengan 100 kan. So ni volume, ni pressure, 0 atm. And then kita compress dia to 90 ml. And then we record the pressure lah. 80, 70, 60. Kita record the pressure. So daripada sini kita akan buat graph of P against V. So awak akan mendapati the graph is going to be like this. Senang cerita dia punya data nanti dia akan jadi from 100 kan, kita start dengan kosong lah. Okay, so dia akan jadi something like this lah. Okay, dia akan keep on decreasing as the volume increasing. Okay, so that is how kita buat kita proofkan this Boyle's law punya experiment. Or we can also do a graph of V against 1 over V, and we'll get a straight line graph. Okay. So please watch the experiment, because I cannot promise you whether we can do it at school or not, because I pun tak tahu bila you guys akan masuk sekolah. I pun tak tahu bila I akan mengajar, physically mengajar. So please watch the videos, the link that I have pasted, I have put in my description for all of my videos yang ada eksperimen. This is what we call as eksperimen wajib. Meaning awak akan buat this eksperimen untuk paper 3 nanti. Tak tahulah eksperimen mana akan keluar, tapi you have to know all eksperimen lah. Okay, untuk application now. So this is the application of the Boyle's law in this world. So first and foremost is of course the shrink. Tadi kita dah tengok eksperimen guna shrink, and dalam real life shrink memang guna Boyle's law. Okay, how do we do that? Ialah kita akan tarik, ni sekarang famous dengan vaccination, right? Have you been vaccinated? Saya dah. Okay, anyway, so ni macam mana dia guna Boyle's law ialah dia tarik dulu whatever amount of benda yang dia nak lah masuk dalam this shrink. Okay, this is really airtight sebab tu kita ada this rubber hitam tu dekat bawah tu untuk airtightkan dia. Jadi bila kita tekan ni keluar, bila kita tekan ke bawah, kita akan create high pressure here. Bila high pressure kat sini, this high pressure akan tolak all the particle untuk masuk dalam this small needle, barulah dia boleh keluar ikut sini. Okay. So that's what happens for the shrink. Kita akan increasekan the pressure dalam ni by reducing the volume of the molecule dalam ni. So bila volume reduce, pressure increase, cara tak langsung dia tak ada pilihan selain untuk masuklah dalam ni. Masuk dalam this needle and then keluarlah ikut sini. Okay, dia akan cari jalan untuk escape. That's what happens for shrink and how Boyle's law is used in shrink. Okay, so first shrink, the second one will be a diver. Okay, diver ni apa dia punya application ni bukan application, I mean example of Boyle's law yang happens for a diver is that dia punya bubble, okay, dia akan bernafas kan. So ada bubble akan keluar ikut sini. Bubble dia ni semakin tinggi dia punya, I mean like semakin dalam diver ni selam, dia punya size of the air bubble will be smaller. Lepas tu dia akan naik atas, dia akan jadi bigger. Because of what? Because pressure dekat bawah ni akan jadi higher than pressure dekat atas. So bila pressure dekat bawah jadi higher, of course the volume dia akan jadi smaller. So volume kat sini akan jadi higher. So that's why bila the bubble from the diver tu move daripada bawah ke atas, dia akan getting bigger because of the difference in pressure. Okay. Tu untuk diver. And the third one is our lungs. Okay. Our lungs ni macam mana pressure dia berfungsi? Alright, so breathe out and breathe in. So when you breathe in, kita buat apa? Kita suck air kan? Kita suck air, oksigen, kita suck air lah. Air yang ada oksigen, ada carbon dioxide, ada nitrogen, ada semua benda tu. Kita suck the air. So bila kita suck the air, of course lah kita punya volume of the lungs ni kena increase. Kalau tidak macam mana air nak masuk? Jadinya pressure kita akan decrease. How pressure decrease? Kita ada diaphragm, right? So diaphragm kita akan relax. So bila relax, dia create a very large volume which cause the pressure inside the lung to be low. So that's why lah air boleh masuk. Sebab pressure dekat luar lagi tinggi daripada pressure kat dalam. Therefore, all the air will be forced untuk masuk dalam kita punya lung. Okay. Because of Boyle's law. Sebab kita dah increasekan the volume inside our lung by the relaxation of our diaphragm. So the pressure kat dalam lung to decrease. Pressure dekat luar lagi tinggi pada dalam lung. That's why air boleh disuck in masuk dalam kita punya lungs. And then untuk breathe out terbalik lah. Okay, breathe out kita nak keluarkan. So bila kita nak keluarkan awak punya diaphragm now, tukar colour lah. Awak punya diaphragm now akan contract, right? So dia contract, dia decrease the volume inside. Jadinya pressure akan jadi increase. So this pressure yang tinggi ni akan tolak all the air keluar daripada kita punya lung. So that's why you can breathe out. Okay, so that's how breathe in and breathe out happens with the application of Boyle's law. Ataupun Boyle's law, apa saya nak cakap? Boyle's law lah yang cause you to be able to breathe in and breathe out. Okay. Okay, now let's go to solving problems. Alright, so solving a problem. A string contains 50 cm³ of air at a pressure of 110 kPa. The end of the string is closed and its piston slowly pushed into the volume of air until the volume of air becomes 20 cm³. What is the pressure of the compressed air? Okay, so this is salah satu soalan Boyle's law. Okay, dia bagi awak this volume, so we call as volume 1, and then kita ada pressure 1, and then kita ada volume 2. Kenapa? Sebab dia kata dia compress the string is the piston is slowly pushed kan, so until the volume of air becomes 20 cm³. So this would be volume 2 lah. So dia nak pressure of the compressed air now. So dia cari P2. So this is where kita akan guna our generalization just now, which is P1 V1 equals to P2 V2. So P2 equals to P1 V1 over V2. Okay, so barulah kita boleh cari kita punya P2 sebab kita dah ada all the values. So 10 kilopascal times 50 cm³ over 20 cm³. So this one boleh potong lah kan. Okay, should we change our kilo or not? Not necessarily, because kita boleh je bagi jawapan kita in kilopascal as well. Okay, melainkan kalau tiba-tiba sini cm³ sini meter cube. That one you have to change lah. But for something yang kita tak perlu untuk mengubah, tak payah ubah. Macam this one lah, okay. Kita punya P2 boleh je jawab dalam kilopascal. Kalau dia letak pascal, pascal lah, tak kisahlah. Melainkan kalau dia kata, what is the pressure of the compressed air in pascal? Then you have to change it, okay. There's no other way to do it. Change it lah. So this is how you gonna calculate. So berapa ni? Mari kita kira. 10 50 would be apa? 50, 100, 500 divided by 20. So 50 divided by 20 would be 25 kilo pascal. That is our answer lah. Okay. So make sense lah kan? When the volume decrease, the pressure increase from 10 to 25 kilopascal. Okay, so that's that for Boyle's law. Now let's go to the second gas law, which is Charles' law. Okay, this guy Charles, dia jumpa Charles' law ataupun dia yang deduce this Charles' law. So he says that volume is directly proportional to the absolute temperature, which is T. Why we call absolute temperature? Because, why do we call this as absolute temperature? Because T should be in Kelvin. Okay, what happened? So the Charles' law states that volume is directly proportional to absolute temperature for a fixed mass of gas at constant pressure. Okay. So tadi kita punya temperature yang constant. Now, because kita nak tengok relationship between volume and temperature, jadinya pressure lah yang kena constant. So pressure constant, jadi V directly proportional to T. So kalau kita buat graph tu, of course lah kita dapat a straight line graph, no doubt. Okay, so let's see how is this happening. Okay, tadi kita dah tengok kan gas law punya gas punya movement or punya things yang affect our gas. So bila temperature increase, kita punya kinetic energy will also increase, especially in a low volume. Sebab apa? Sebab dia apa aku cakap ni? Sorry. Okay, so in Charles' law dia kata bila volume increase, temperature increase. Okay, tadi dalam that closed container kita tengok kita tak ubah the volume. Tapi what happen bila kita keep the pressure the same, and then this one kita allow the gas to move, jadinya bila temperature increase, all this gas molecule akan ada more kinetic energy, right? So dia akan bergerak dengan lebih pantas. Bila dia bergerak dengan lebih pantas, dia akan tolak this piston naik atas, which at the same time cause the volume to increase lah bila dia tolak this piston naik atas. Sebab dia laju kan, gas dia laju dan penuh tenaga, kita boleh kata. So dia sampai tahap boleh tolak this this piston naik atas. So that's why volume dia akan secara tak langsung increase. So that what happens when T increase, V also increase. Okay, so the graph is just a straight line. T and V, or V or T, doesn't matter. Okay, so T is again a constant. K is a constant. T is just a temperature in Kelvin. Okay, remember, temperature should always be in Kelvin for gas law. And the volume, of course lah, meter cube or centimeter cube, doesn't matter. Okay, alright, so kita buat sama je macam tadi, macam kita buat pressure law tadi. So kita ada V equals to KT. So K will be equals to V over T. Okay, now K equals to V over T. Okay, now again we have two situations here. Kalau orange pula. Okay, so now for example kita have V1 equals to KT1, and then we have V2 equals to KT2. So from here kita akan dapat K equals to V1 over T1, and then here kita akan dapat K equals to V2 over T2. So the generalization would be V1 over T1 equals to V2 over T2. So this will be the generalization for Charles' law. Okay, anything involving Charles' law, we can use this formula to find the temperature or the volume. Syarat dia apa? Syarat dia pressure kena constant. Okay. Kalau pressure tak constant, we can never have all this Boyle's law. Kalau pressure tak constant, kita tak akan boleh guna this formula. Okay, because it doesn't valid anymore. So, untuk Charles' law, pressure kena always the same. Okay. Alright. Let's see the experiment. Okay, experiment for this one. Dia lebih complicated daripada Boyle's law because kita nak varykan dia punya temperature. So we have to have ice, we have to have this Bunsen burner to supply heat kan. And also kita kena ada satu indicator yang untuk volume lah. Okay, so indicator dia apa benda ialah kita letak dalam satu capillary tube, kita letak satu dot ataupun beberapa ml of concentrated sulfuric acid. Okay, kita letak concentrated sulfuric acid dah, and then kita letak dalam that tube ataupun capillary tube. Okay, dia akan hanging dekat capillary tube tu. Okay, and then kita ada thermometer to check on the temperature. Because later on want to take data kan. Kalau tak ada thermometer macam mana kau nak ambil data. Alright, so now. Okay, so now kita buat apa is, kita heat up this. Sebelum kita heat, kita ambil dulu ice water. Ice water should be 0 degree lah, okay. So kita ambil dulu data for 0 degree. Temperature and volume now. Tak nampak pula. Okay, temperature and volume now. So temperature 0 degree Celsius. Wait 0 degree Celsius. So the volume would be berapa? Volume dia kita tengok dekat ni lah, pembaris ni. Okay, volume of this, the length of the air column kita panggil. Okay, sorry ni bukan volume lah, length of air column. Length of air column. So length of air column dia berapa cm? Okay, cm, so berapa cm? And then when kita heat it up, kita panaskan dia, so kita akan tengoklah temperature berapa yang kita nak, thermometer yang kita nak 10, 20. This one you set lah, okay. The temperature you set because ni kita punya manipulated kan. So kita nak tengok length of air column je. So bila dia 10, dia kat mana? And then bila dia 10, of course lah, this length of air column will expand. Gas will expand dalam ni So dia dah dipanaskan kan. So this concentrated sulfuric acid akan naik atas. So bila naik atas, length dia akan jadi lagi tinggi lah, lagi banyak lah. So awak kena kena record for each temperature the length of the air column. So actually the length of air column ni dia represent volume of the gas, because the longer the length of air column, the more the volume of the air inside this lah. Okay, the apa kita panggil, the gas to expand. Bila dia dapat more energy, dia akan expand, dia akan bergerak lebih laju. So dia akan tolak this acid naik atas. So bila dia tolak this acid, meaning volume dia increase. So bila kita buat graph, kita akan dapat V against T lah kan, sebab T kita punya manipulated, V kita punya responding, T kita punya manipulated. So kita akan dapat graph directly proportional. Okay, so this is the experiment for Charles' law. Okay. Alright, so let's discuss the application of Charles' law dalam this world. Ada banyak lah, but this one I take only the only three untuk explain. Okay, first up is hot air balloon. Okay, hot air balloon, I bet semua orang pernah tengok lah kan. Even if you tengok cerita Up kan, yang dia naik balloon pergi naik atas tu kan. Okay, so hot air balloon, kat mana dia gunakan Charles' law? Dekat, okay, so this is the balloon, and then ni dah ada cat raga, orang boleh duduk kan. Okay, so this hot air balloon ni kat tengah-tengah dia ni, dia akan supply heat. Okay, api heat. Okay, kenapa dia supply heat? To heat up the gas inside the balloon. Okay. So remember saya ajar dalam specific heat capacity before yang hot air dia less dense. Okay. Cold air dia denser. So less dense ni dia akan naik atas, cold air akan turun bawah. So bila kita heatkan the udara dalam this balloon, so temperature increase kan. Volume also will increase, volume of the gas. Volume of the hot air gas will increase. Bila increase, dia akan jadi banyak kat sini. I mean the volume is more. So when the hot air volume punya, apa aku cakap ni? Bila volume of hot air lagi banyak, so dia akan jadi dense, very less dense. So dia boleh float lah. Dia boleh float. Okay. So itulah application of Charles' law dekat hot air balloon. So this, apa benda yang kita buat kat sini ni yang menyebabkan our balloon boleh float. Alright. The second application is bread. Kat mana bread ni? Okay, bread. Bila kita masak bread, bila kita bake a bread, kita guna apa? Kita guna yeast kan? Dalam bread ada yeast. Okay, this yeast, kita nak bagi sebelum awak, kalau awak memang seorang baker atau awak seorang yang pandai baking, you will know that this yeast kita nak activatedkan dia, kita kena guna air suam. Okay, air suam plus sugar sikit, bagi dia makanan sikit so that dia boleh mengembang lah. Okay, boleh, sebab kita nak roti kita fluffy. So kita nak roti, kita nak roti yang dense. Roti yang dense mean roti yang sangat padat, which is tak sedap. So kita nak roti kita fluffy, lembut sikit, baru sedap makan. Jadinya to make this fluffiness, okay, so our yeast lepas deactivated kan, kita akan campur dengan apa? Campur dengan tepung, campur dengan everything lah yang kita nak dalam kita punya bread tu, yang kita bakar. So bakar dalam oven, right? So oven kita ni suhu dia, kalau oven saya selalu saya guna 230 degree Celsius, which is panas lah kan. Panas gila. So this hot temperature akan menyebabkan volume of the yeast ataupun of our bread ni akan mengembang lah, volume of the gas sebenarnya. Yeast, bila kita activatedkan dia, dia keluarkan CO2, carbon dioxide. So this carbon dioxide ataupun the gas inside the bread yang akan increase in volume bila kita letak dalam tempat yang panas. So bila dia increase in volume, that's why kita punya bread boleh mengembang macam tu. Ni walaupun dia ada all this air pockets ni kan. So dia boleh mengembang because the gas inside the yeast and also yeast yang ada dalam bread lah expand. Okay, the volume increase. So that's why kita punya bread pun mengembang dengan jayanya dan masak dan sedap dan yay. Like that. Okay. So kita guna Charles' law. And the next one, the next one kita ada turkey poppers nama dia. Turkey time poppers. Bila kita nak bake a turkey, ni selalunya kita jarang lah. Macam Thanksgiving, orang putih ataupun English people, diorang ada Thanksgiving kan. So, diorang makan turkey, right? So, they're gonna bake this turkey inside an oven. Tapi, untuk kita nak tahu dia dah masak ke belum, they are using this one. Nama dia turkey popper timer. Timer popper, something like that lah. So, apa yang berlaku ialah, bila turkey ni dalam oven, dia akan panas lah kan? Akan panas. And this one also akan panas lah. Sebab akan berlaku kat sini thermal equilibrium. Okay, whatever heat yang dalam turkey ni akan transfer to this little thing. So this little thing, dia punya benda ni akan expand bila temperature increase. So dia akan expand to some extent. Dia akan expand sampai tahap dia pop keluar. Okay. Dia terpop up keluar because of the expansion of this thing. Okay, the poppers lah, poppers to expand. So meaning ada increase in volume. At some pressure, dia akan pop up keluar. So bila dah pop up keluar, maksudnya turkey kita dah masak. Meaning kita masak turkey based on some temperature yang kita nak. Sebab kalau over bake ataupun kita terlebih masak, turkey kita akan jadi tak moist lah, tak juicy. So this thing dia reka untuk pop keluar dekat certain temperature sahaja. Bukan semua temperature bila dah kembang dia keluar, no. Okay, contohlah dia nak temperature, dia nak turkey dia tu dalam 180 degree lah contoh. So 180 degree ni menyebabkan turkey kita akan jadi moist and sedap lah. So this thing dibuat untuk pop keluar bila temperature 180 degree C menggunakan Charles Law punya principle. Okay, which is menggunakan the expansion of the volume. Okay. So I hope you understand. You don't understand, macam biasa, tanya. Alright, so now let's solve a problem for Charles Law. Okay, so the problem for Charles Law is, okay, so let's solve a problem involving Charles Law. Okay, an air bubble trapped under a leaf in a lake has a volume of 1.6 cm3 at a temperature of 38 degrees Celsius. Calculate the volume of the air bubble if the temperature of the water in the lake drops to 26 degrees Celsius. So we have the same bubble in two different conditions. Satu dekat 38 degrees Celsius, satu dekat 26 degrees Celsius. So dia nak suruh kita cari volume dalam 26 degrees Celsius. Okay. Alright, so of course kita boleh guna kita punya formula tadi. V1 over T1 equals to V2 over T2. But, tadi kita dah tengok temperature kena in Kelvin. Okay, so now kita nak V2. Kita nak this one kan. So, masukkanlah 1.6 bahagi 36 tambah 236. 38 tambah 273 equals to V2 divided by 20. What happens to me? 26 plus 273. Then you will get V2 lah. Okay, using your mathematical technique or whatever. Okay, using your mathematician brain, so you can find this, right? In cm cube. Of course lah, sebab kita tak ubah pun kita punya this one in cm cube. Let it be in cm cube. Okay, unless it's ubah. Okay, so that's that for Charles Law.